All right, thank you. Everybody, welcome. Thank you for coming to our Rust Meetup group. I would normally ask how many of you are first time to Rust Meetup, but I think most of us, right? Because, it's been a year and a half since we've done this. To begin with, let me just continue. We do these talks every once in a while. We don't necessarily have like an official cadence for it. We generally just say, hey, somebody wants to talk, let's have a talk. And so if any of you want to have one, let me know and I'll be happy to schedule one for you. Talks can range from any level, like from I'm thinking about learning Rust to I've built a really amazing tool and I want to show it off to the world. A little bit about I guess like me, I've been organizing it for about year and a half, 2 years. I do a lot of streaming on Twitch, and so that little side business is one of the sponsors for here, and we're going through u.rs on my Twitch stream. And our other sponsor here is Mersive, this lovely space, this lovely food, and the great drinks. I don't know if either of you want to say anything about Mersive. Before we get too much into it, does anybody have any announcements? We usually do some community announcements here.
Anyone looking?
Yeah, I would say I think we can offer that. Like we are actually hiring Brent, do you want to talk about what the role is?
Yeah, we have sort of a data engineering team that gets data from our 100,000 pods into the cloud, stores them in heterogeneous databases. We're looking to do we're kind of in an interesting spot where we're getting to like piecemeal rewrite stuff. So there's a lot of opportunity to work with new technologies, new stacks, reimagine things. And then we have a front-end full stack team that is generally doing servers in TypeScript, loading that data, presenting it to users, doing visualizations of it in our cloud dashboard. So if you fit either of those descriptions and you're looking for work, come talk to me or Tom or anyone from Mersive afterwards. And in addition to that, we've got all kinds of fun Python and Java, and we work on drivers and the Linux kernel and C and C++. So whatever you're looking for, there's some of it here.
We do a little bit of all of it.
All right, last little things are, we are live streaming and recording this. So people on the live stream, if you have any questions, just ask me and I will be happy to forward those questions on. Same for people on Zoom. And then anybody who, let's see, I will also have a recording of this on YouTube afterwards. We'll put a link into the meetup page and on Twitter or wherever you hopefully found out about the meetup. With that, you didn't really come here to see me talk a lot. I would love to introduce Brent, our speaker for the night. I met Brent when I was working at Galvanize with him. We were both instructors, and you were in the data science area. Was it data science or enterprise?
I was all over.
Yeah. Anyways, you did a lot of traveling, you did a lot of teaching, and I'm looking forward to hearing a lot about Rust from you.
Cool, thanks. Appreciate that, Brooks, and thanks for putting all this together. It's good to be meeting again at all, and it's good to be meeting in person. So yeah, speaking a little bit about Mersive and like what we do, this is being put on this display right now and streamed via our, we have a Internet of Things pod, IoT device that allows you to do wireless screen sharing. So this laptop is not plugged into that screen through a cable. And what it's doing is all those devices that you see, this professional grade audio equipment is connected to it through Wi-Fi. And the talk that I'm about to give says a little bit about how we made that happen. So me, myself, I've been a coder, taught for a while in Galvanize, worked with Brooks and others there, and got into management here in the last 6 months or so at Mersive, and got the opportunity to help the cloud team re-architect, reimagine the cloud side of our product offering. So just a couple of caveats, like I am not a Rust expert. It's kind of been a year since I worked on this code. And I worked professionally on Rust for about 6 months. So I think there'll be many people on this call who probably know more about the language than I do. And so I'm totally open, like to make this kind of free form. So if you have any questions and you're in person, just raise your hand. And likewise, if you're on Zoom or Twitch, then just raise your hand virtually. We've got Tom and Brooks watching those feeds, and so they'll just voice your input. So yeah, as Brooks was saying, like this can be kind of laid back. Like I throw myself on the mercy of the crowd. When I've done this before in the past, everyone's been super nice. It's been a great group and very welcoming. So kind of what we're hoping for, I think, is just that if you worked on a fun snippet of Rust in last year or whatever, you want to show it off or just think it's neat or have questions about it. You know, somebody might have better ideas how to do what you did. And that can be a presentation. We can all get together and have pizza and beer and have fun. So I think if you talk Tom into it, Mersive might do this again sometime. And,
Yeah.
cool. And so, yeah, the final component is kind of us at Mersive. Like we originally were about screen sharing. We're like in all the WeWorks in the world, as far as I know. So we were very much in person. We were headed towards remote offerings, like we're integrating with Zoom right now. And we kind of think the future is hybrid meetings. So this meetup was like a perfect opportunity for us to talk about hybrid meetings and show off our technology as well. So with that, I would be remiss as a teacher if I did not talk about objectives. We're going to talk about USB, but the main thing that I really want to convey here is Rust and features and async. What we did is we had like a bunch of different modules that needed to talk to each other. We're using channels to pass those messages, and due to the low-level stuff that we do, that was all unsafe. And it was sort of okay. But I thought to myself, what would it look like if I really wanted to wrap this in a more idiomatic API that was preventing the caller from seeing any of that unsafety? So this was, I thought, a great opportunity. A lot of the examples that I saw online that talked about futures were sort of like either really simple examples that were like, you know, basically like thread.suspend or whatever the async equivalent of that is. Which was really boring, or like complicated examples that were like, okay, fire up Tokyo and go make an HTTP request. Like, don't worry about the magic behind the scenes. So I thought this was like a real applicable way to explain what somebody might do with async and await in Rust. I guess before I get any further, like raise your hand if you've heard of async and await, coroutines, futures, Tokyo. Okay, cool. So like everybody's at least like at least familiar with the terms in here. So yeah, we're gonna use a futures API to wrap some unsafe code. We're gonna use select all to create a ring buffer. We're hopefully gonna be able to describe why futures are desirable in this context, like what might make them idiomatic. And you know, if we can become a little bit conversant upon USB terminology. I think we're going to need a little bit of this just to drive the discussion, but I'm going to try not to go too deep. If I start to go down a rabbit hole and you see me pull up Wireshark, stop me and let's talk about that afterwards. Any questions before we dive in? Here online. Cool. Let's go right for it. So, what is this crazy use case we got going on here? So the diagram that you see is sort of the world as we know it today, but in, let's say, 2019, 2020, really the only parts of this picture that existed was this MacBook here, this Wi-Fi, this pod, and this screen. Like all we did is replace the HDMI cable between your computer and the screen. Which is pretty awesome, right? COVID strikes and people don't know if it's airborne and they don't want to be plugging cables into their computer. And frankly, who wants like a table full of dongles anyway? So that was pretty cool. But increasingly, as there were remote participants in these meetings, everybody wanted like what we have here, like professional grade sound bars, audio equipment, sometimes like phased array microphones, like picking up the particular speaker, and cameras that can go pan, tilt, zoom. So clearly you're not going to want to put, if you didn't want to plug in one dongle in your computer, you're not going to want to plug in like 4 or 5 and install some Logic type software. So what we did is we did some clever trickery where we were able to transport USB packets over Wi-Fi, over IP, encapsulate them, made a Windows driver that gets installed when you install our client, and it makes it appear as if you just plugged all this USB equipment like virtually into your computer as soon as you connect to a screen. So you don't have to plug any of this in, but you still get the benefits of all that professional grade equipment. So I don't want to get into all that, partially because it's proprietary, partially because it's be the rest of the talk. I'm just going to focus on the audio stack for right now. And this sort of came out of, we ended up, like this was originally in C++, we rewrote it in Rust because the original version was unstable. Our device runs Android. We can run libUSB on our Android device. Clearly we wanted to like encapsulate this, but with what we were doing with low level bit shifting and packet fiddling, we needed control over that. So we were actually playing audio directly to the USB device, skipping the operating system, the kernel, all the mixing, all that stuff. So in this particular case, I extracted a logical part of our whole app that could be a public GitHub repo on its own and refactored it to have an idiomatic API that plays a sine wave. So like you can clone this repo, you can do cargo run, and if you have this exact hardware or you want to go fiddle with settings, then you can play a sine wave. So that'll be our goal for today is hopefully hear some audio come out of this thing. So this is the demo device. We'll share out links to the slides later. You can go take a picture of this if you want and purchase that on Amazon. It's about 15 bucks. Why on earth did we get this device working? Well, it was COVID and I was keeping my wife awake with like playing crazy noises out of like these giant speakers. So ironically, our best supported device is like a USB audio DAC that nobody's ever going to use in real life, but you know, it helped. So again, jump in at any point in time here if you have questions, or just raise your hand. So sort of the crash course version of this, just things that we need to know for the presentation, is that USB drivers are normally like kernel level things, and writing kernel level code is hard and prone to crashing the kernel, which nobody likes. So libUSB is a handy library that exposes this on Linux platforms, well, and Windows and others to userland. So you can just write regular old C code, but we saw some problems with that and embraced Rust. So there's sort of this convention within the Rust community to wrap native libraries with a -sys crate. And that is just like running bindgen. So you can take the C header files, you can run bindgen on them, you get out some Rust code that calls that DLL or SO file. You push that up to crates.io, and now you have a Rust wrapper that is totally unsafe, very unidiomatic, and it will be like writing C, but grosser. So then what Rust stations usually do is then go wrap that unidiomatic library in an idiomatic one. So in our case, we found RUSB appeared to be one of the most mature idiomatic wrappers around libUSB. But unfortunately, the one thing that it did not do is isochronous mode, which we'll define in a minute, which is how audio works. So that wasn't great. So other things that you need to know, USB devices have classes. This is like how you have a Bluetooth profile. When your phone connects to your car, it knows it's a car. It knows what a car can do. Same thing with USB. We'll be talking about the audio class today. USB devices have interfaces, and interfaces have modes. There's sort of these 4 modes, which we'll get to in a minute. Control, bulk, interrupt, and isochronous. We're going to be dwelling on isochronous today. Again, audio goes through isochronous. USB is request response based always, which was a surprise to me. Like the host always sends a USB request to the device, and the device responds to that request. Becomes important here. And then number 10, like if you want to play audio, this is happening really fast. So like the bus is leaving the station at like, millisecond intervals or 250 microsecond intervals, depending upon your USB speed. And so you're not going to write application code that like gets that timing correct. So you have to create these buffers that go to the OS. Who knows what happens after that? Somebody smarter than me. OS must send them down to a controller somewhere. So what we have is like your application generally has to keep a ring buffer populated. So you allocate n number of buffers. We copy Linux. Windows does 2, Linux does 3. Linux is like 10 milliseconds a piece. So you create like a 30 millisecond rotating buffer, and you want to keep that as small as possible to keep your audio delay down. But on the other hand, if you miss the timing interval because it's too small, then users hear choppy audio, and that's not super good. So that's kind of our goal here, is to set up one of these ring buffers. And I think the nifty thing about Rust was, I know we have some JavaScript developers here. If you're familiar with promises, as I was, because I taught them at Galvanize, it's a great way to submit an action for execution and then get a result back at some point in the future. For Java developers here, this is completable futures. For Rust, it's futures. For Golang, it's Go routines. I haven't written much Go. Everyone's got this. Python's got this now. They're rewriting everything. So it was a really cool way to use a promise of something happening in the future. So I kind of wrote some like JavaScript inspired Rust here, which I thought was pretty neat that it could, bring the lowest levels together with the highest levels of coding. So a little bit about these types again, like control. Control is the boring stuff. When you plug in a device, your operating system asks, who are you and what bit rates do you support and what classes do you have and how many interfaces and all that. So this is like USB control traffic. Nothing too special. Interrupt is interesting. Like I'm moving in my mouse here. You can't see it. Oh, you can. So I said it's always request response. So how do you deal with devices that are providing input like that? Well, you just always send requests, and then that device just responds when it detects a movement or something. So interrupt is basically that. And I think there's some OS level abstractions to like make it less annoying, which brings us to isochronous and bulk. And the easiest way to define these, I think of, is like, if you've ever ridden a train in Europe, you can buy a ticket that's just like, I want to be on the next available seat on the next available train, and there may or may not be one. Or you can buy a ticket for a specific seat on a specific train at a specific time of day. So what we're doing here in isochronous mode is, if those packets are leaving the USB host with a fixed interval and fixed size, you're reserving X number of bytes per interval. So it's like QoS, you're taking a portion of that USB bus. So if you know you're going to play audio at 128 kilobits, you've got 5 gigabits of USB 3 or whatever, you can just allocate 128 kilobits and you know that you will have those seats reserved. And if you miss them, user hears pops, nothing, something. So yeah, real-time devices, like USB sticks tend to be bulk. Real-time devices tend to use isochronous mode. Wireshark, oh man, I feel like I gotta skip past most of this. I think suffice to say, I don't like reading RFCs. Let me rephrase that. When I read an RFC, it's because I've already like hacked it down to the bits myself, and I now actually need to read the documentation, and I'm humbled. So usually the way I like to do it is fire up Wireshark and see what happens. So you can follow these commands on the right. You can sniff USB traffic. So that's what I did. You can kind of see some control traffic at the top, and then you can see like these final 2 control packets and then a bunch of isochronous stuff. So if you look really closely, and I don't have a good way to zoom this, actually zoom this, slide. You can see what happens is at 798 microseconds after the 10th millisecond, the host sends 3 packets of 1,312 bytes to the device. And then they start coming back, oddly enough, 82, 10 milliseconds-ish apart. So then after that, it's device host, host device, device host, host device. So it's a ring buffer. We're watching a ring buffer play out. And we could go in and look at all that, but we won't. So, okay, I know what the operating system is doing. I've sniffed it, like, great. Logically, all I need to do is make these same packets happen, and then Bob's your uncle, right? So what are we doing here today? Let's talk ring buffers in like school bus rock kind of fashion. So computer allocates like 3 transfers. Like this is a libUSB sys concept in this case. So you're telling USB sys like, hey, make me a transfer. What is it? I don't know. You just get a handle to it. It's a pointer in memory. So libUSB sys, we get those back. We say how big we want them to be. We put them on the bus. Bus delivers them to a queue on the device, controller, wherever. And with this weird representation I have here, transfer 0 is playing right now. It's in the speaker. Transfers 1 and 2 are sitting there in the queue. Let's keep going. So what happens? Transfer 1 completes. It's played 10 milliseconds have passed. The speakers played the audio. 0 goes back on the bus. It returns to the application code. Application code's like, cool, I see you're done. It tries to fill that packet back up with new audio and then put it back on the bus and so on and so forth. So it's just 0 1 2 0 1 2 over and over again. And hopefully if you don't screw that up, you have consistent audio. And then recording is interesting and much the reverse. You're sending like empty buckets, I like to picture it, and the device is filling those buckets up and then giving you the data back. All right, great. So now we know all about USB and audio. How do we make that happen in Rust? Well, you Google for USB crate, you find our USB. You maybe look at our GitHub repo over here. Again, we'll share some links. So you start coding. So that is enough about what we're trying to do conceptually. Let's, for the sake of like me running long, jump straight to the end. Talk about like, what was I trying to achieve here? Like, what was this promise-based fever dream that I came up with that I thought would be a good API? So this is essentially the code that I hope we're going to end up with. This talk could go 2 ways, like depending upon the amount of questions I get. I'm optimistic so far. We'll keep on track. I don't know. You guys are a little bit quiet.
I got a question.
Okay.
You said that it's a request response based thing. Is that dictated by the plug type or something? What negotiates who's the master on the network? I assume it's party line. I'm assuming the serials and the names, it's like TX is wired together. One master sending packets out or saying like, hey, here's an empty bucket filled with some data. After you've already sent some sort of negotiation to a device, when it comes online, say, hey, I'm going to go on this. What happens?
Do you see Justin McBride online?
I don't.
Host to device, the host is always going to make the request, and the device is always going to respond with the response. And the device in this case would be the speaker, and the host in this case would be the laptop.
So you plug a USB-C cell phone, which is capable of being posted to a laptop. Like, who's the daddy of this relationship?
So in that case, a phone is typically in front of the dual device, and it can be either the host or the device. When you plug it into a laptop, it would be the device. But it can also act as a host. You can also plug the speaker or
And what's that setting called on Android that allows you to flip that? On the go, USB on the go allows you to switch it. I don't know what that looks like at a wire protocol level, but I like to think about it as like the old school Ethernet hubs where there's like.
It's literally a resistor, so you have to switch over to 10 or something like that.
There's like wires going out and there's wires coming back in is like how I like to think about this. And the hubs know because the wires.
On the serial part of it. So I assume this port is on the port and it has a interrupt of some kind, it has a buffer of some kind. Either of both sides of this, right? Is that how it's really fits it? I'll let you know.
These are some great questions. I am gonna use my teacher thing and bring us back to the objectives.
Sorry.
Yeah, like low-level USB, out of scope. Like to focus on like Rust async await questions more than USB in particular. I only go so deep. How far I got was like that Wireshark thing. Like I know about the OS contracts to whatever the controller does. And as far as the wire goes, like we have some like wire protocol people, but I can get you in touch with them to answer those questions afterwards. Or talk to Nathan, because he knows pretty much everything. You laugh. So yeah, like what could we do here? So what does a futures-based API look like to do this Wildcat stuff? So what I came up with is a desired end state is kind of this, and hopefully we'll live code through it to get to here, but maybe not. So first of all, we have like a global mutable variable sample index, just like we're going to try to populate a sine wave in a bunch of buffers, and this was about the easiest way that I could figure out to do that. Kind of thinking about this like application code, like this stuff you don't want your application to think about, but you're gonna have to fill out audio data. And so like this is, imagine this was some other streaming source or something. So we got the sample index that keeps track of that. Xfers, I find Rust gets very long. So my own personal style has been to like keep these lines relatively short, was to like abbreviate private variable names and then keep public variable names like a readable contract. So if you see Xfers, I mean, a vector of transfers. So we've got this global config thing that has a bunch of just boilerplate settings. So we're going through our buffer count, which we said we're copy Linux is 3. We're just going to allocate a bunch of new transfers, which is going to do some stuff with libUSB under the hood. And it is going to push them into that array. Okay, that's boring to me. Like this is what starts to get cool. Submit transfers to bust. Like, so this is great, right? Take a page out of functional programming. We've got a vector of transfers. We can get a mutable iterator on that. So we can map, like if we, back to JavaScript, we've got an array, we can map it. What are we mapping it to? Well, for each transfer, we've got a submit method. And so that submit method returns a submission, which we collect into a new vector. So we map our array of 3 transfers into an array of 3 submissions, and those have been sent to the bus. So now what we have to do is wait for our submissions to complete, and we know that the audio has been played. How do we do that? We make an infinite loop. Sort of okay, because we're in like coroutine land, so we're not actually like tying up a thread necessarily if we don't want to. And then the select all thing was the most deceptive part of this all to me. I would have called select all, select any. If you're from JavaScript, this is promise.any. It's saying of this array of futures, return to me, or rather await on it, suspend until the first one completes. I don't know which one's going to be the first one. I don't care. But as soon as any of them are done, this await is done. So that select all macro gives us back, actually it's a function, gives us back 3 things. It gives us whatever the return value of the future was. So the future is completed, like it's no longer a promise of a thing, it's now the thing. And that is called res here for result. There's an index, which is saying out of that array of 3, which one of these completed. We don't care, it's an underscore. And then there's the complement. I don't know what you call this. It's the rest of the ones in the array. It's like suck the one out that's done, and it gives you back the array of ones that are not yet done. So we can unwrap that nicely with using anyhow for error handling everywhere here. Looks like just about everybody else is familiar with it. So cool. I don't know much about it other than like it makes my error handling super nice, so I use it. So we can then, one of the things the results has got, sorry, did you have a question? One of the things the result has got, because we put it there, is the index. That's kind of important because the index in this complement array is not necessarily the index in our transfers array, and that caused some bugs that were very hard to diagnose. So we can grab the original transfer back out. We can resubmit it, which is filling it with the next part of the sine wave. We can push that into our complement array since it's mutable. We can assign the submission, the complement back to the submissions, which means when we go back through this loop, we've got a new loop of entirely uncompleted submissions. And so I thought this was a pretty cool way to use futures in like a practical way. Reflecting on this, I wanted to go further before this meetup, but I didn't really have time. I would love to turn this into like an iter. So I think if I had another week or whatever, I'd probably make a new struct called like ring buffer, have that implement iter, take this code, put it into there, and then just have an infinite for loop over my iter, just allowing me to populate the buffer with my next data. And then I think all this would truly boil away. But I thought this was a pretty good learning opportunity. If you use futures as a consumer, then that's great. You know, you don't have to know a whole lot. You just need to make sure that your function is async and you're like in an execution, like some kind of context that can do async. And you just need to make sure that you call await. And then by the time your call completes, you get a response. However, like I think the real fun part comes in like implementing futures, like as a producer, because that contract is slightly more complicated. So I thought this was like a great opportunity. What I'm going to show you is working code. It matches pretty much what I described initially, in that it will play USB audio, but it's just doing the unsafe libUSB stuff. It's got a callback, which is literally a pointer in memory, and it'll jump to there and it'll put a message in a channel, and we'll just iterating through our channel. And that's cool. That's not a horrible way to do it, but I thought this async thing was slightly cooler. Yes.
I have a question. Sample index is set to 0 in this, and I'm not sure why that is. So I thought I would ask. Can you repeat the question?
Oh yeah. So sample index here is set to 0. Why is that? I'm going to show you a couple of functions here. In order to make this live code as simple as possible, I created some boilerplate functions. Like one of them is populate buffer. And so that takes in the position in the infinite sine wave of where I am in time. And then it fills the buffer with the bytes for the sine wave. So that's what this is tracking. It's like, how many samples into this infinite thing am I? So it's like the phase of the sine wave.
So the base is the modifier.
Correct. Yeah, it's kind of gross. It's the one gross thing. Like, I guess if I wanted to be pure functional, I'd have a separate function to fill it versus submit it. And I'd probably have the fill function return the new value, and ignore that for now. Other questions before we move on about end goal? Because we might not get there. I might start live coding and it might be 7 o'clock and it's time to go. Cool, nothing online? All right. So yeah, what is the boilerplate? So the scaffolding that I put here, let's start from sort of most boring to most interesting, or maybe in chronological order, I don't know. So this thing starts up, libUSB has a concept of event loop. It doesn't allocate any threads on its own. So like you have to just allocate a thread and just constantly call poll, or else it won't do anything. Open device is relatively straightforward. It just tells our USB to open device and give you back a handle. That's safe until we reach down into the guts and pull out isocronous buffers. Fill a buffer, that's what we were just talking about. Just nothing magical there, just doing a sine wave function. Submit, calls libUSB, puts a transfer on the bus, and then Isocomplete Handler. This is the like nasty, gross, completely unsafe callback to function pointer in memory that we want to like get as far away from our nice, safe rest as possible. Questions about any of those functions? So yeah, future signature. What does that look like? Let's just code this. That would be better. Oh, cool. Actually, sorry. So now we're in, like I have a branch. You can check out this branch. It's starting in that initial state. So this task 1 thing up here, this is saying like, if you follow these tasks, then we can refactor this into the glorious futures-based nirvana. So let's try and follow these instructions. Well, first let me run the code, make sure that it even works at all. And then let's try to make our submit function. Let's refactor our submit function to return a future. And then we can use like sort of error-driven development here. Well, then it'll break. Well, what happens? Well, we fix the bug and then we go on. So if I'm really lucky, well, for one thing, let's check Git. Cool, we are on the correct branch. And so if I hit play here, it should run this program. That did not happen this morning.
You couldn't see the code, I think, but it wasn't showing yet, so I think it's okay.
Gotcha. But everybody heard the tone. Hopefully the people online heard the tone. Oh, yeah. So yeah, my wife Rachel is actually why this $15 DAC is the best support of any device in Solstice conference. So I could play that tone at 2 o'clock in the morning when I was coding without waking everyone up. So yeah, let me collapse some stuff so we can try to like focus on the interesting stuff. And I realize I should zoom too, so. So yeah, out of those functions, is anyone curious about any of them enough that we should start diving into the guts? You got a question about fill buff? Let's just use that as a guinea pig to test the waters. So it takes a buffer, which we know the size of because it's a vec. It takes that sample index, volume, iterating through bytes or uints because it's 16-bit audio, doing a dot sine wave, scaling it, and making it 5% volume so that we don't all go deaf.
I see that submit function.
Yeah. So what does submit look like? Zoom windows.
Yes, this is where the sample index is being mutated by the unsafe fill buff.
Fill buff, yep. So submit is doing both. It didn't originally, and then I just ended up towing these two functions around everywhere in my code. And so I just said, you know what, this will be a lot easier if we just put one inside the other and then live code, you know? I'd be totally open to doing that a different way in real life.
It works, man. I hesitant to refactor. Rest the borrow checker kills it.
Yeah, so we fill the buffer. This is probably an interesting part. Box new, and then box into raw. So like essentially what we're doing, so there's sort of several structs here that go along the way. So we have a transfer. That's the thing we're allocating from libusb. That's got an index, the buffer, and the reference or pointer to the libusb transfer. And then we submit it. Yeah, I believe submit right now. Yeah, so the trouble is like libusb has this user data thing, which is just like a PTR void to whatever you want. So you need to store something in there or else when this completes, we don't know anything about what just completed. So that's what we're doing here. Like we allocate a new transfer context with any data that we're going to need later. Then we create a box around it. So it's got a pointer on the heap. And then we do like a box into raw, which allows us to get like a C void out of there and like do the unsafe interrupt. That's probably the only like magic sort of like out of the box in this initial state. I guess if we're talking submit, then I guess the next thing that we probably want to talk is Isocomplete handle. Well, actually, Alec, there's some magic there. So we call libusb alloc transfer. I said like unsafe Rust looks like really like C, but grosser. Like dereferencing this pointer everywhere. But more to the point, when we allocate it, we just one time say like we call our Isocomplete handler for any of these transfers. And then we attach the buffer to it. And there's also like, this is literally like USB packets. So like we're looping through there. There's n number of packets as part of this transfer because it's 10 milliseconds worth of data. And if we are at super speed, then there might be 250 microsecond intervals. So like this is actually like an array of packet headers and then an array of data to fill those packets. But the important part here is Isocomplete handler. when you allocate the transfer, we're saying, come back, call us back here when you're done. So that was submit and allocate. So now we're in Isocomplete Handler. This is the inverse of that. So we've passed ownership in a logical sense. Like when we did into raw, we told Rust's borrow checker, just forget about it. Like you can totally leak this resource, but we're passing it to a unsafe native C library. That thing owns it and it's going to call us back and we trust that code. And here though, it would just leak forever if we didn't do this. This is my understanding. I'm totally open to correction from anyone here. Like if I walk away with more knowledge and better code, I'm very happy to, so speak up. But from what I understand, this box from raw then takes that pointer, puts it back in borrow checker land. Rust now knows about it. So when this scope ends and DTX goes out of scope, it'll actually free that memory from the heap that it had allocated before. So don't worry, we're safe again. We're just unsafe for 10 milliseconds and now it's cool. And then the next struct that comes in here is transfer result, and kind of seeing where like have initial struct we submit, and then one that goes along for the ride, and then one we get back. So that's kind of the life cycle of this right now. Here we're storing the index. We've got a status that could have like been successful or failed with an error code. Yeah.
I've got a comment for you. Marvin says, I'm surprised to see box new, which performs heap allocation right next to buffer filling audio code. The golden rule of audio coding is to never allocate on the real-time audio thread. Why won't this box new cause dropouts?
That's a great idea. I would ask if you can pre-allocate a pool of boxes to do the same thing. I would think that you could. We should probably be storing the boxes instead and not letting them drop out of scope. So that, correct me if I'm wrong about any of that, but I think that was very valid feedback and that would be how to deal with it.
That would be a better way of doing it instead of allocating.
See, it works. So we said earlier, asking for presenters. Yeah, you know, I just learned a thing. And I like that. It was just super nice. I felt like it was like a gentlemanly pull request. So actual length, this is less important when you're playing audio. If you're recording audio, like proc drift and stuff, like you might not get back a full sample, like you might be a couple of bytes short or long. And finally, we're like taking that result, shoving it on our totally safe channel, not really caring about what the result is in this case. Probably also get some feedback about that. So yeah, that's kind of how it's playing right now. If you look at our main, it's really just calling run. Part of that's to encapsulate an unsafe. Part of it's to deal with the async stuff that we're maybe about to hit if we still have time. And the real logic is happening here in run. So in this version, we pull down, we're allocating those transfers. We're creating a channel with the sender and receiver. We're submitting them all three initially. And then as we receive those messages that we've sent down the channel in Isocomplete Handler, we're receiving them out of that channel here, and we're grabbing it and resubmitting it. So as I said, aside from that like heap allocation, it's not a terrible way to do it, but I think we can do better. I think we can use futures and async. So just kind of like questions about initial state before we start our way into a live code. Cool. Whew. All that takes me back to the slide. Make, submit, return a future. So let's do that. So our function here is called submit. And right now, it looks like it's returning a result of nothing, unit, or error. So I'm just going to go ahead and say, I think what would be logical to me would be if it returns something called a submission. I'm just going to make a struct. I'm going to call it a submission, and it's going to return that instead. Cool, we've got a struct. And I think we can just stick it here. And I don't know, do we want a constructor right away, or do we just want to do that? Okay, let's just do that. Cool, so really nothing should have changed. We're still playing audio, cool. Let's go back to our slides, make it return a future. Well, am I returning a future yet? Not really, I just made a struct. So in order to make this do what my slide says, we info future. Futures colon future. For submission. Awesome, and that's why I didn't want to look at the API earlier, is because my IDE is yelling at me. Thank you very much, Sea Lion. Cool, so if we autocomplete it, it says we need to define a type. And right now it's just defined that as unit. We've got a single method called poll. It's got a self with a pin, which I'm going to gloss over, partially because I don't understand, a context, and it returns some output of the enum type poll. So, and it's to-do'd it, and I'm kind of happy with that for right now. So this is great. Now that we've made it implement future, what do we think is going to happen if we hit play? Shout it out.
Are you awaiting your future?
I didn't type in await yet.
Nothing?
Thanks. So yeah, it's doing the exact same thing it did before because we're not awaiting on it. Good intro. So what happens next? Well, returning a future doesn't do any good. Like you saw that we implemented poll, and poll even had a thing that's gonna panic, but nothing called poll. Like you can just create futures all day long and nothing's happening on them. So I would posit that a more interesting thing to do here would be to call await. Oh, await is only allowed inside of an async function. Okay. Oh, my function's async. How cool is that? So,
There you go.
sorry, what's that?
There you
Question mark operator. Oh, so now it's complaining because I don't have an execution context to be async on. So I'm gonna use futures, executor, block on. Cool. So this will just like use my main thread as a context for running coroutines. Did I say that right? Stations. I'm getting a thumbs up here. So awesome. I don't know if anyone heard that, but we got 30 milliseconds of audio, I'm guessing. So if I look at the logs, transfer submitted, index 0. Oh, we only got 10 milliseconds of audio. Man, I got good ears. It's like I debugged this crap for 6 months. But why? Why? Poll. Poll is what panicked. Oh, on line 70, our to do. Well, of course, now that we called await behind the scenes is called poll. And so it's trying to do a thing. What should it try and do here? Look if it's done. That is a good guess. However, we haven't told it to do anything yet. Or have we? Yeah, actually we did. Because submit filled the buff and boxed it into the raw. So it did actually submit it, which is why we heard that 10 milliseconds of audio. So you are absolutely correct. I think this code doesn't belong here. Like the idea behind futures is like you create one and just like promises, you take the body of what you're going to do, you move that into poll. So you've created that future that's about to do the thing, and then when you actually call await, that's what kicks it off. So I think we're kind of like disobeying a pattern right now. I'm going to do this and just return. What was it? Submission, curly braces. Oh yeah, and that's not very rusty, so I'll get rid of that. And there's no reason to have an error anymore. That's going to be an asynchronous error. So boom. And then we can go into submission, go find this to do. Well, now we know what we're doing, right? We're just doing whatever the heck we were doing when we submitted it, but now we're going to wait until poll. Okay, now we got some problems. Fill buffer. Actually, I take that back. Life is going to be easier if we just do that in submit. So let's fill the buffer here before we submit it. Like we know that we're not going to resubmit a transfer that hasn't completed, so it's safe to fill it here. Now we just got some compile errors to fix. So yeah,
You drafted a whole type then to return this?
sorry, can you repeat that again, but different?
Never mind. Keep going. Keep going down the path you were going. And
How
also,
long do we got, Brooks? Am I trying to hit a hard stop at 7 or?
You don't really have a hard stop. It's whenever it wants to go home or first wants to pick us up.
So yeah, sort of.
Hopefully, yeah.
So with 5 minutes left, like show of hands, like who wants to like jump to the end, look at the commits, like skip the live code part and just go fast? Or who wants to keep it rolling and go through this bit by bit? All right, I'm getting more keep it the rollings, so we're gonna keep it rolling. So I don't know, like I think I heard like the beginnings of a question that I'm gonna interpret as like, where did this exfer come from? Well, we lost it back in the submit function. So what do we do with it? We don't have an exfer, but we could have a this or a self. So I'm thinking what we do is just on submission, we start defining some members, stealing them liberally from submit. And I mean, the thing that I really like about this exercise is it drove home for me anyway, that despite all this crazy future stuff, like we're really just refactoring here. Like I've got some data over here. I just need to move it over there. So like in this case, I know that exfer has something called IDX. Why am I not auto completing here? Oh, duh. So I'm going to define a property on submission called IDX. I'm going to copy exfer.idx over to it. It's a use size, so that makes life really easy. Just copy it. It's an integer, don't care. Cool. So we fixed one compile error already. But now what? It's complaining about this exfer.exfer, so I'm going to do the exact same thing. What is it? I don't remember. Let's go down and look at our function signature. Let's just call it exfer, point it to exfer.exfer. Oh, and it just said right there in autocomplete, it's a star mute libusb transfer. So I know that I'm going to need to go add that to my submission. Cool. So hopefully that goes away. Oh, it's complaining now because of unsafe. Did we get all of the, that might be all the members that we, oh, result tail is still not a thing. Surprised I don't see a compile error for it. Probably because the IDE is still complaining about call to unsafe function. Okay, we know this part is unsafe. Okay, so now it's complaining because this is one of the rough things with like trying to do whatever. I'll stop my language diatribe. What it's saying is that we are returning an okay or an error, and what we need to return is one of these poll classes. So if we submitted our transfer and it goes back a 0, that means it's pending. So we're just going to say, hey, poll enum, or returning pending. That's our present state. So the whole point of this like future is it's essentially like a state machine. We're gonna see how the state advances. The first time it just gets advanced by when you call .await, it invokes this poll method for the first time. Later, we're gonna see it get invoked again. So it's poll.pending, and I'm just gonna go ahead and say if we got an error back from libusb, let's say it is a poll.ready. It's a little bit ironic, but if you think about it, like features. Sorry, what's that?
Said we're ready to give you the error.
Exactly. It's a future of a result of a value. So in this case, like, yeah, we're ready and we got an error, which now I think it's complaining about because I think we already had the transfer result class hanging out. So let's use that. So I was just changing this output type that before was a unit. Now we actually know what we're going to return. It's a transfer result or an error. So now it looks pretty happy. That we've got one more compile error. Or 4. Okay, so result tail. That was our contract, an Isocomplete Handler. When it finished, we were going to go put the result in the channel, and it's trying to put the result in the channel, but we don't have it defined here. So I think this just needs to be self.resulttail.clone. We'll do the same thing. We'll say result tail is a sender of. Does anyone remember what it was of? Yes, thank you. Sender of transfer results. So we have one and we can clone it and put it in the context. We need to pass it along here. And the great thing about channels, and the thing we're going to get to in a minute, is they're all designed to be thread safe. So like you can just clone them all day long, use them from whatever thread you want. So it's just easiest to clone it here. I believe that's cloning some kind of shallow copy thing. And then just some like cleanup for selfs here. Okay, question mark operator. So we definitely always return a submission now. So we'll just not worry about that error case. Hopefully. Not borrow self is mutable. I think we can just make that mutable. Oh, unsafe block doesn't include pointer stuff here. We're pulling the raw pointer back into a box, so that's unsafe. Cool. When I saw this the first time, so I guess if you can't read this, oh, I can zoom, cool. Submitted, transfer 0, transfer complete. So we fixed that error. It's calling poll. It's not panicking because there's no to do anymore. It has submitted our transfer. The Isocomplete Handler got called because it says transfer complete down here. It hasn't even bothered to submit the second transfer. What's going on? Now's when it's never ready. Yeah, we've returned pending and ready on error, but we've never returned ready like I got a result. So the next question would sort of be like, well, how would you? We're going to need to return a poll from this function, but how's this function going to know when something somewhere else in Isocomplete Handler finished doing its job? Yeah, but something's got to actually invoke this function too. And I don't want to necessarily do that from some other unsafe function. But I noticed I got this parameter here. It's called CX. It's context. That's kind of interesting. So what does CX have on it? Bunch of normal stuff, borrow, deref, mute. Oh wait, a waker. What the heck is a waker? Well, a waker is a thing that is also thread safe that allows you to pass it around between threads, do whatever you're doing. Whenever you call waker.wake, it's going to reinvoke poll. So I said the first time the state machine was advanced, it was through .await when you initially await on it. But then you can keep invoking .poll as often as you want with this waker as you go make network requests and read and write from drives or play audio or whatever you're doing. So we got to go save that waker so that we can wake this thing back up later. Which we could do just by, again, thread safe, slap one of those guys on here. Choose task waker. Let's hope.
There's a comma right on the line above us, yeah.
Oh, thank you, thank you. I was expecting this, which is, I think it's complaining because we can't, like ownership. If we're gonna need to clone it to make that happy. Cool. So yeah, we've got a waker, and then I think you're absolutely right, Vincent. In Isocomplete Handler, we've got our thing, we put it on the result tail. It's still going back into our queue, but now we have the, I think it was the context.waker.wake. So now hopefully our first await is going to go through. It'll actually put all three messages on the bus. We'll see it play more than one. So maybe we'll get 30 milliseconds of audio, maybe not. Ooh, that sounds terrible. That is audio with 10 millisecond gaps in it. And if you look, yeah, for those of you on Zoom, we see index 0, complete, index 0, complete. So we got a ring buffer that's not really buffering in a ring super well. So, hey, progress, right? Different error. So what are we doing wrong here? You remember the bus, what we wanted to do when the bus first leaves the station, bless you, we want to fill it with 3 transfers. And so when we did our await there, we're awaiting on each submit.
So we want to batch these.
Now this API actually gets to be fun. So we can say, we can store our submissions. So that needs submissions. I think we're going to want to say a vec underscore so it knows what's going to be. Yeah, I'm iterating over my xfers, and they're going to need an iter to iterate over. This is one of my pet peeves with Rust. Figure that out. And then we can map it. So each one of those is going to be a transfer. And then again, just refactoring. We're really not changing any logic here. We haven't done any big logical leaps. We just want to submit that transfer, collect them all. This thing goes away.
That wanted to be a colon.
I did, thank you. Mutables make mutable? Thank you, Sea Lion. Lovely. So I'm not really sure what's going to happen here. I think what's going to happen is now we're not calling await anymore. Nothing's going to happen. I'm right about that.
Yeah.
Yeah, so the fun way to. So yeah, I think for the folks on the phone, Yeah, we're submitting these 3 transfers, but nothing's waiting on them. So we're getting back a VEC of submissions that aren't doing anything. But we know we can't await on each submission because badness ensues. So how do we await on all 3 submissions at once? And that's where we get into the features executor select all. Feature select all. I gotta admit, like, all the different futures namespaces is still one of the most confusing things to me about this.
My first time looking at it, happy.
Well, cool. I mean, now you can go home and clone this repo and at least have some exposure to it.
Yes. And my project. With the benefits that
So cool. The select all is just gonna take the whole array. It's gonna wait on the first one that completes. So we're gonna get something back. Yeah.
Can you guarantee that that will include the submissions in order? So if you have like parts of the sine wave, can you guarantee with that it's going to be sent in the right order? Or
I can guarantee I sent them in the right order because I submitted them in the right order. And I can guarantee if I don't get error codes from libUSB, then the speaker's going to play the first one first. And so, yeah, it should, God willing, do everything right.
Guarantee it's USB, and then if you complete it in order to remember, if it was a different type of feature that wasn't with USB, I suppose that could happen in that order.
isn't that the way a channel is under the hood? It has to. If there's a queue that is successful.
I think so, yeah.
Not sure. Since I don't know the same.
Does submit edit to the channel? No, it's the callback.
Sorry, louder? Oh, okay.
Working through it extra.
No, that's fine. Like, I mean, if you have a question, somebody else probably has it too, so.
So it's only added to the results channel once the callback happens inside the list.
Yeah, sorry, now that everyone's like willing to hang out, like I can take my time and answer these questions. I'm sorry if I was rushed before. But yeah, it's adding it here in the Isocomplete Handler to the tail of that queue. Which actually isn't relevant for what we're talking about. The important thing is it's calling the wake, and the wake is going to cause that to complete. So the select all is going to complete. So we know that one of them played, and we got the index of it.
Why is the bar checker component, or why is the submissions red line?
Use the move variable. So let's handle that. So we're not doing anything with what comes back from that. So I said that was a result. This type completion is awesome. Like, I'm glad that I can see right now result, transfer result error, but it really confuses me typing. We get the index and then we get the complement. Like, there's everything but that. So what it's complaining is I'm moving submissions into select all, but I'm doing it in a loop. So the second time through this loop, it's the use of a move value, and that doesn't make us very happy at all. So what we can do to fix that is assign submissions to something new. So it's now has a new value for the next iteration through the loop, and we can assign that to the complement. And now it'll do something different. I don't guarantee that we're going to like what it does different. All right, so what we saw here was a submitted transfer zeros, transfer one. Oh no. So somewhere up here I have config, which was just my hard-coded constants. Oh no, I've got the lazy static here where I'm initializing my config, and I said buff count equals 2. I don't like that. Let's say we were copying Linux. Let's copy Linux and do 3. I think it's more illustrative. If you maybe heard that, there's a little chirp of 37 milliseconds worth of audio. So what happened was we submitted transfer 0, 1, 2. they completed. Looks like then we got some kind of exception. And the exception is an assertion failed on is empty. What happened? Well, it said the complement was the remainder of them. So we played the first one, it now has 2. We played the second one, it has 1. We played the third one and it assertion failed and blew up. So how do we fix this error and make sure that we keep having things to play? I like it. So we have complement and we want to push something to that. So compl.push, and we said the empty things. So the transfer that played, say that is now emptied, like the speaker just emptied it out. Cool, I like it. So we can't, why can't we do that? Louder?
Copy on the mutable reference.
Yeah, that's not untrue. That's one of those red squigglies. It's not a submission, yep. So we need to take our transfer and resubmit it. And then what we're really trying to put in this queue is the submission. Okay. Odds on whether or not this is going to work? Let's find out. Oh, okay. So our res here is a result of transfer result error. So we need to like unwrap this, but everyone knows unwrapping is bad. So we'll do res.context. So anyhow, this is super cool. Anyhow, just lets you go throw something in there. I'm going to say failed to select. And question mark that guy. Cool. Now we have a transfer result. Oh, that was like 3 samples played. They're complete. I'm legitimately stumped. What's going on? Okay, I'm not stumped. I think we have a dangling queue somewhere. Remember how we were taking our results and we were shoving them onto a queue? And we were calling waker.wake. And so we're going back into poll, and poll's up here. What tells poll whether this is the first or second time that it's called? I said .await would call invoke poll the first time, right? And so poll's going to try to submit this transfer. And so the only 2 paths out of here are pending an error. And so waker's going to wake it and it's going to come through here and it won't know how to do anything else except call that same code and return pending. So this promise is always pending. We're advancing the state machine and it just keeps advancing forever. Yeah, so let's do one last code refactor and I see eyes glossing over. So let's just kind of like blaze through this. So I'm going to kill that channel. This was like an MPSC or something, like it could live for a while. I think we should replace this with a 1-shot. Again, allocation problems notwithstanding, just allocate a 1-shot each time and then destroy it. And that way there will be a way for the waker to tell the poll the result that it got back. And in real life, you should probably pre-allocate these things, not in an audio loop. I'm just going around taking away parameters that had queues that we no longer need. Literally, you could just follow the trail in your IDE, get the same thing.
Light mode is very difficult.
Oh, sorry.
I'm guessing you're in the minority with light mode.
Teaching, battery life, presentations, working outdoors, a bunch of things just all added up. Yeah, this is actually an OLED, so. Battery life outside, like it's much easier to see this in a high contrast setting. Okay, so I got rid of almost all those. I think we probably still have a spurious import up here somewhere. Let's get rid of all these MPSC things, or better yet, let's change this to just one shot. Ooh, double entendre. So in one shot, I've now replaced those with the correct things. Oh, is that not what they are? Futures channel one shot. Cool. We replaced all those with their one shot versions. And then what I think we can do is when we create our submission, we keep the result tail, but we make this optional. Because we're only going to use this once because it's a one-shot queue. And then we can also use that as a Boolean flag of have we called this before? Is this our .await or is this our wake? And now the difference is I think we also need to store the head. We're just going to be allocating this ourselves. So now we've got both a head and an option of a tail. And so now in our new constructor, which we never made, name. And I guess we'll do it here. It's tail first, right? I believe this is it. Actually, it just showed me tail is the sender, receiver is the head. We're passing along a clone of the tail. I don't think we just pass ownership of it. We also need to pass the head. Sorry, what's that? Okay, cool. And actually I was wrong. We need to result tail is actually a sum of result tail. And then finally, back up here, this is what we were doing all this for. So now, first time we come through here, we're gonna have a result tail. So what we need to do is actually mutate that. So we can, since it's an option, we can take it. So we can say if let sum result tail equals take, I want to say. Oh, optional.
Option.
Yeah. Take. Cool. So we're going to take that value out of our optional. If it's sum, we're going to do exactly what we were doing before. If it's none, we're going to panic.
I have a stupid Rust question.
You should absolutely ask it.
If let syntax is preached, and I'm thinking to myself, what am I gaining from not doing that compared to match?
You could absolutely match here as well. Anyone?
Am I gaining something? Or losing something? You don't have to have the else, but in this case we do. So we're actually not getting the benefit of the like, because we have the else, right?
Well, so you're also getting the benefit of television from a psychology point of view, because you'll get two options.
Yeah.
So when you read if let you can go, there's a binary expression.
I see it.
We're about to do some super cool stuff with match though, which like.
Yeah, I always match. I always think more functional style of match. So I guess it's just case. Our rule of thumb is if it's more than two, it's match. If it's like one, maybe two, if that's fine.
So when I first came to functional programming, one of my questions was like, what's the deal with pattern matching and why is it better than a switch case statement, which is like evil and terrible, right? I've seen nested match statements. And when I realized like, oh, okay, you can do what we're about to do. This is what really sold me on on pattern matching. So this is a poll of a result. No, this is a receiver of a transfer result. Shoot, I'm like losing it here. Yeah, we want to try to receive. So we've got the result head. We can call try receive. Try receive will try to receive. So you get back an option, but it's an option of a result. A result might have a okay or an error. And so you need to like a 3-state matching. Like, is this not yet done? Is it done success or is it done failure? And if that was if lets, then you'd end up nesting them. But since it's a match, you can just like do all of that in like one nice flattened nested thing. So I love that. Anytime I can flatten out code, I love it. And it scares me whenever I see like pet peeve here, to each his own or her own. Whenever I see somebody set to like 2 spaces for an indent, I'm like, what are you doing? That needs your tabs to be so small. So yeah, we definitely have a head now, but it may or may not have anything yet. So we can try and receive it. So we're matching on this. Help me out here. Returns a result. So you need to.
Let the ID do the work here.
So is this, am I on the right track here? I feel like I'm missing some syntax. A result would be okay. For the result, no, this is okay with a sum for the result, in which case we are poll ready for the result.
I applaud you for writing that out. I would never have done that.
What would you have done?
You said on match, it's redline, that you said all enter that.
I practiced this 3 times before, as one does in a live code. You do not want your trust your IDE on auto-completing this one. Funsies. Yeah, so this is complaining now, I think, because it's not a transfer result. It's a, okay, I don't know. I'm gonna not.
I can't trust what we're going to see it, right?
Do something that's technically valid.
Add remaining patterns, error. It's just error underscore. And I said we wanted to do like a.
No, I'm just kidding.
Is this right? It's a result of an option. Oh, it wants a result, and we've actually got a transfer result. So it's an okay of a transfer result. Okay, none. This would still map to pending, right?
Yes, we haven't done the data yet. We haven't done the error. That's ending.
So we've advanced the state machine, but for whatever reason, I mean, this is, we should probably panic, honestly. Like, this is just, I don't know what the hell's.
Making it up.
Yeah.
Baker, yeah, it seems like that should never happen, most likely.
Or finally, we've got the error state where we're, again, ironically, ready. And I don't know if this is anyhow magic. Why can I do this? I can error dot from error. And I think this just like, actually, sorry, I can do this. So this error?
Yeah, which error is that?
Anyhow, pubstruct error. Okay. Anyhow, it's just magic. Like, you can just turn anything to an error. Awesome. Okay, so now we're actually putting our thing in a one-shot queue. We're calling wake. That's all down here in submit. So we're sending it to our waker. Back up in poll. We will wake back up. We will no longer have a result tail because we've consumed it. So now we know we're on the second pass through this, or at least the nth pass. We try to receive. If we got nothing, then honestly, like I said, this should panic. If we've got an error, then libusb returned an error to us and we queued that. But hopefully we got an okay of sum of transfer result. We can pass that back up. Now we're back in our run function down here somewhere, and we get that transfer back out. We resubmit it. Life goes on. Hopefully we've made a ring buffer in a way that anyone who's dealt with JavaScript promises can understand. So that tone sounded terrible at the beginning of this lesson. I really hope that it is like music to your ears now that you know all this API stuff.
Difference between the 3 done and 1 sentence.
Come work for Mersive for about 6 months, work on audio, and you'll be able to tell. Cool.
Back all this over to you, your TCP or something. What's the challenge?
Buffering,
Latency,
transcoding.
wait too long to get that response back to the USB bus. And it times out and then the USB device gets into an error state. And the time you have to get it to send the response is like way less than what your network latency is going to be. So you have this really complicated stuff. Yeah, anyways.
So you introduce yet another quarter second.
All right, I'm going to stop Nathan before he gives away all of our proprietary information.
I don't think I'm the same way.
You are welcome to hang out for a while. Ask Nathan all those questions. I just wanted to thank you all for coming out. Brooks, do you have any last notes?
We just had lots of like claps and little comments, but not really any questions from online.
Awesome. Tom, do you have any final words? And then anything from the audience?
Thank you.
All right, thanks everybody. Take push this, by the way. I might want to say, I'll tell everyone that this actual version is committed in case anyone wants to look later.
All right, I'll make sure, if you give me the, are you gonna give the slides also?
Yeah, let's, after this is over, before you go, let me get that all that to you.
Yeah, I could then push it up to the meetup page and then the.
Cool. Thanks a lot. Come work for Mersive.
It's great. Yeah, it's actually just bypass the operating system. You go right to USB.
Yeah, it's still.